All right, here's our normal program. We have a few extra headers up here, standard io.h, string, standard def, and standard lib, so that we can do some of these other things that we're going to do here in the program. We have an argument counter, our argument vector, and environment pointer. This is a new one that we haven't talked about in the programming series. We had our argument counter and our argument vector before, and you notice I've changed my form just a little bit. This is pointer to pointer. That's the same as an array of pointers. Same thing with the environment pointer. Nothing's changed, of course, in the language or the way it works. This is just the notation. We have the double pointers, and that says it's a pointer to a pointer. Same thing over here. Then we have a couple of local variables. We have local variables Q pointer, which is going to be a pointer to our query string, and then a separator, just a single character that we can work with. We print out our header, because we've already done this before. Remember, header is going to be of type text HTML, so that's going to call down here to our function we had before that just prints out our content type header and then returns back to the main program. This has to be done before we put anything else out to the browser. We have to get that content type out there right away. So I always do that first so that I don't accidentally try to send something to the browser without that header. If you do that, you'll get an error guaranteed every time. Here's our start of the page, and that's a title. So we get our little form handler title out there. And then we're going to say, oh, they clicked on our form. We do a blank line, start a paragraph. They clicked on our form just to say that we're here. And then we're going to start looking around inside the environment to see what they said to us. First of all, we will check get environment, GETENV. When we do a get environment call, we give it the name of the environment variable that we want to look for. And in this case, it's query string. In a little while, I'll give you a program and show you how to write a program that will let you see all of the environment strings that come to you, because there's a lot of information there. And CGI gives you a lot of information about who you're talking to as a browser, what kind of browser it says it is, the host that they're coming from, their IP address, the host of your server, where your CGI program is located, all kinds of things come to us in the environment. In this case, the one that we care about is the query string. So we'll get to see here, first of all, if there even is a query string. So if this returns true, get environment does in fact have a query string, it will return it and put that pointer into Q pointer. If this returns null or 0, the if will fail and will fall down to the else of the if, and say the query didn't come through at all, and we'll print, oops, we didn't get a query string, and then we'll do our end page and we're out of there. Well, let's hope that doesn't happen. So we'll come in here, we'll say that we do have a query string, and I set up some locals that are local to this code block because they're not needed for very long. So I just tucked them away inside here rather than clutter up the rest of the program with them. We have a local buffer, 256 bytes long. Hopefully that's enough to store what we need to store. We still are going to handle the information carefully because if somebody wants to overflow a buffer, this is where it's going to happen. So I make a pretty large buffer. I make a character pointer called token, we're going to use here in a minute, and I create a first name and last name array, each of them 80 characters long, to hold our first name and last name. The first thing we want to do is copy this value that came in the query string from where it sits in memory into the Q pointer. We're gonna copy the whole thing over. Well, we have the Q pointer. We're going to copy it into this buffer. From Q pointer into buffer. Maximum of 255 characters because we have a 256 character buffer. So we don't want to take a chance of overrunning that. So we keep track of how many bytes to handle. Sometimes bad guys will send you hundreds and hundreds or thousands of bytes of data in the command line trying to blow your program up. And that's what a buffer overflow would do. If you just took what they gave you without controlling it and controlling the size of it, they could send you a ton of garbage in here and cause your program to blow up and then give them a possible opening into your system. So here we are going to take what came back as the query string, put it in the buffer, and then we're going to start to take it apart. I need to show you another slide here because I lay this out a little bit better than we see it in code. There's our form handling. We already looked at that, first name and last name. and then I want to show you what this is going to look like. When a form uses the get method, as we said, we get an environment variable named query string. Query string contains everything after the question mark. So in our case, when we run this, and you haven't seen it yet, but this is what it's going to look like. We're going to see a question mark, and then the first name equals, in my case, I put in Tim and Hegarty for those two yellow text fields for the first name and the last name. And this is the way it will come through to our program, hw2.exe. What we need to do, and what I was starting to show you in the code, is we need to split the string on the ampersand, which is right here in between our variables, and on the equal signs, because first we'll get first name equals Tim, and we'll get another item called last name equals Hegarty, and then we need to split on the equal so we get the actual data values out. Okay, we'll use string token and scanf to do that work. We are not going to watch for encoded characters in the string. If I put some odd information in here, it'll be encoded and it would come in with %20 for a space, that's hexadecimal 20 for decimal 32 or a space character, and that's called encoding. And we're not going to decode these strings. That's up to you to start to do some more research, and now that you understand that it's coming to you, you can learn how to parse these URLs out and understand what the encoding looks like and how to accomplish that. What we're going to see in this code is a way to do it, not necessarily the best way.